Time travel. It's the stuff of science fiction, right? We've seen it in movies. A hero hops into a time machine, zooms into the past or future, and changes history. But what if I told you that time travel, in a way, is possible? And not just in the movies, but in real life. This isn't a wild fantasy, it's based on the mind-blowing laws of physics. And by the time you finish this video, you'll understand how time travel could work, and why it might already be happening. To get started, let's take a step back. What exactly is time? We all think of time as this straight line, moving from the past to the future in one direction, always ticking forward. But here's the thing. Time is not as simple as it seems. In fact, time is connected to space. This is what Albert Einstein discovered with his theory of relativity. Imagine the universe as a giant fabric called spacetime. In this fabric, both space and time are woven together. Whenever you place something really heavy on this fabric, like a planet or a star, it bends the spacetime around it. Kind of like how a bowling ball would bend a trampoline. And this bending of spacetime doesn't just affect space, it affects time as well. This is where things get really interesting. Einstein discovered that the closer you are to something massive, like a planet or a black hole, the slower time moves for you. This phenomenon is called time dilation. Let's say you're an astronaut, floating near the edge of a black hole. To you, time seems normal. But if you had a friend watching you from far away, they'd notice something strange. You're moving in slow motion. From their point of view, your clock is ticking more slowly than theirs. So technically, you're aging slower, you're traveling through time. Now here's where it gets even crazier. This isn't just a theoretical idea, it's happening right now. Believe it or not, GPS satellites orbiting the Earth experience time differently than we do on the ground. Because they're moving fast and are further from Earth's gravity, their clocks actually tick faster. Scientists have to constantly adjust these clocks, or GPS would become inaccurate. So, in a sense, the satellites are living in the future compared to us. But if you really want to travel through time, you'll need to go to the most extreme place in the universe, a black hole. Black holes are like cosmic monsters. They have such intense gravity that even light can't escape. But here's the wild part. If you got close enough to a black hole without falling in, time would slow down so much for you that you could see the distant future. Imagine this. You're near a black hole for just a few hours, but when you return to Earth, millions of years might have passed, you'd have traveled to the future. But what about going back in time? That's where things get trickier. According to Einstein's equations, moving faster than the speed of light might allow us to travel into the past. But here's the problem. Nothing we know of can travel faster than light. Not even the fastest spaceship. However, there's a loophole. A theoretical object called a wormhole. Picture space and time as a folded piece of paper. If you want to go from one side of the paper to the other, the fastest way isn't to go across. It's to poke a hole through the paper. A wormhole could be that shortcut, connecting two distant points in space and time instantly. If we could find or create a wormhole, we might be able to step through and emerge in a different time, maybe even in the past. But there's a catch. Wormholes, if they exist, might be incredibly unstable. They could collapse or behave unpredictably, and we don't yet know how to safely travel through one. Now, before your head starts spinning, here's the fascinating twist. Time travel into the past might already be happening, not through wormholes, but in tiny particles called muons. Muons are subatomic particles that live for only a fraction of a second before they decay. But when scientists smash particles together at near-light speeds in particle accelerators, something incredible happens. Muons seem to live much longer than they should. It's as if they've time traveled into their own future. This experiment shows that time, under extreme conditions, really can behave strangely. So, does that mean we'll be building time machines anytime soon? Probably not in the way we imagine in movies, but here's the mind-blowing part. Time travel, in some sense, is already a part of our universe. Whether it's astronauts aging more slowly in space, GPS satellites experiencing faster time, or particles like muons bending the rules of time altogether, we're already glimpsing what might be possible. But let's leave you with this question. If time travel is possible, whether into the distant future or even back to the past, Would you do it? And more importantly, how would it change the world if we could truly master time? The universe is full of mysteries, and time, it turns out, might be the greatest mystery of all.